So I'm bastien Buffechoux, CEO and co-founder of Qperfect company. And our job is really to help developers of hardware and software to go fast and enabling the quantum computer revolution. So we all know that quantum computer promise a revolution, and especially on a lot of domain. But this technology is still at its 40s if we compare to classical computers. And everything has to be redeveloped, starting from the hardware, which use a completely different physics, but also algorithm, which use a very different approach to code and solve problems. Nevertheless, today, developers really lack from tools to solve such a complex problem. If we look at hardware developer, usually they have to develop their own model, which usually rely mostly on the quantum system. And the accuracy of this system really depends on the time and the money they spend to develop it. Then if they want to test their ideas, they have to do it on real device, which costs a lot and really take time for them. The other aspect is for software developers. When they will want to test complex algorithm, either they need to have access to hardware, which has non-control environment. I mean, especially gate fidelity. But otherwise, they have to rely on simulation, emulation, to test their circuit with low scale. So, like Cadence or Synopsys does for classical computer, Qperfect proposed the first digital development environment to support hardware and software developers. We will offer the possibility to build a full virtual quantum computer based on a library of components, protocols, and atomic models. And then to evaluate directly on the digital, in our environment, the performance of their choice in terms of software and hardware. And then for software developers, they will be able to test large-scale software to move toward quantum advantage. So our fully fledged virtual quantum computer is built on different modules. And the first one, which is a large-scale quantum circuit simulator, able to simulate up to hundreds or even thousands of qubits, depending on the entanglement of your circuits. And you can already have access, free access of this tool if you go on our website. And then there is a module in which you can build brick by bricks your digital twin with the best accuracy ever attained in the market. And in this tool, we will also provide a library of technologies to really push further the performance of the QPU, especially on error mitigation and error correction. Also, our core expertise is on a cold atom platform. We will be able to deploy our technology to all optically addressed qubit platform. So in terms of business model, so we'll provide our tool, which named Mimic, as with a web access, and we can also provide it on a desktop. No HPC will be required to run our software. This tool will be also a showcase of our technology we will develop, and can be used really on our tool, and can be accessible through a licensing to be implemented in the real hardware and then sell to clients. And our last revenue will come from services to adapt our technology to our users. So although Mimic will be at the core of our business, we really rely on our library to seek growth of our company through licensing in the future. So that's our team. The technology we use on the on our technology on our company now come from a public laboratory in Strasbourg, especially by leaders in their field in experiment, theoretical approach and numerical approach. And they were especially recognized by obtaining French financing to develop a niche platform in Strasbourg based on cold atom. And they are also leading the Eureka quantum flagship program to enable the next generation of cold atom platform in Europe. And from my side, I developed an intensive experience in innovation management, especially working more than 6 years in a technology transfer organization in Strasbourg. And so to be the leader in digital development environment, we are working in our first fundraising to develop a user-friendly offer and performant offer. And this fundraising will be also used to develop our library of technology and to prove our capability to sorry, I forgot the word in English, but to bring technology able to go further in terms of performance of quantum computers. Thank you for your attention.
One question here about all the hardware players, they release their own emulators. So for example, if you take Pascal in Code Atoms, they have a Pulsar. How do you plan to compete with that? All these tools are free.
That's not the same emulators. We go clearly further in terms of performance, in terms of circuits, and that's not on the simulator. We would like to make money. It's really on our digital twin, where no one is now. So that's where we want to find the market, not on our circuit simulator, clearly.